Hello everybody. Back when I was doing consulting, I ran into lots of issues over and over again when I was doing query tuning. Little things that stood out as red flags, and often they were easy to resolve, but sometimes they really were not. The cool thing is, back in 2017 and also in 2019, Microsoft added some new features to SQL Server, to the optimizer called Intelligent Query Processing. And Intelligent Query Processing, or IQP, takes care of some of those issues, some of those red flags that cause problems with query performance without changing code. So that's what I'm going to talk about today. Before I get started, I want to mention some of the really great things from PASS. For example, they have just started a new pro membership where you can get exclusive benefits and exclusive training. I signed up a couple of weeks ago and I'm really excited about it. Over the years, I've been involved with lots and lots of the local groups and the virtual groups. SQL Saturdays. Back before the pandemic, I was attending typically one SQL Saturday every month. Now I'm involved with a few of the virtual ones, and it's really a great opportunity for you to attend a SQL Saturday, especially if you've never attended one before, because now they're all within reach. There are other great benefits like PASS Marathon and the 24 hours of PASS. I don't really see mentioned here, but those are back-to-back sessions by industry experts, MVPs, book authors, some of your favorite speakers. So be sure to check that out. I've been a proud volunteer of PASS since 2004, and I encourage you to look for ways that you can get involved with PASS as well. Please, please, please fill out your session evaluation. Your feedback helps us understand what we're doing well, what we're not doing so well, and helps us improve. So be sure to turn those in. If you get those in by Friday at 5 p.m., you will be entered in drawings to win some prizes. I'm Kathi Kellenberger. I work for Redgate Software, and I am the editor of Simple Talk and also a DevOps advocate. The most important thing to know about me is that I'm a lifelong learner and teacher. I love to learn and I love to teach other people what I know. I'm also a data platform MVP, and I'm co-leader of the Women in Tech virtual group at PASS. I'm also a volunteer with the wonderful program out of St. Louis called Launch Code. Today I'm going to really break the presentation down into 3 sections. First of all, I'll cover the features that came out in 2017. Then I'll show you the newer features, the ones that I'm really excited about in 2019. And then I'll take some time to explain how you can control whether or not these features are turned on for you and how you can make that very granular if you need to. If you go out and do a search for intelligent query processing, you'll come across Microsoft's documentation site, and this image will be at the top. And that kind of shows how these different features are kind of laid out. We've got a few that came out in 2017 and more that came out in 2019, which you can tell from the colors. However, some of them, for example, memory grant feedback, was available only in batch mode in 2017, and now in 2019 it's available in row mode. So what's the difference? Batch mode means traditionally that you need a column store index involved in the query in some way. So in 2019 you no longer need that for memory grant feedback. But another cool feature in 2019 is that now we're getting batch mode on regular Rowstore queries. So these are the ones we're going to be taking a look at today. First off, the 2017 features. First one I want to talk about is batch mode adaptive joins. This is by far my favorite in the 2017 group, definitely by far. So sometimes, and I run into this constantly at customers, You have parameter sniffing going on, where if you have a parameterized query or a stored procedure, that maybe it runs fine with one parameter, but then it slows down with another parameter. And part of the issue is that maybe a table or an index scan is good in one situation, and maybe the index seek is good in another, or maybe it has to do with the way that things are joined under the covers or physically joined, be that a nested loop or a hash match. So what this particular feature does is allow the optimizer to switch back and forth between those two depending on the number of rows that are coming through. So it's based on a row count, and at least at this time, it does require that a column store index be involved with the query, at least now. So I'm hoping that these features really get expanded a lot over the years, so we'll wait and see what happens if this ends up being a Rowstore feature as well. It's also Enterprise Edition only at this time. You'll also see a new operator in the query plan. If you take a look at the query plan, this adapted join operator. So let's go ahead and take a look at an example. And there's my example. I'm using several databases throughout this, 3 or 4, maybe 3 different databases throughout this. And this one I'm using Wide World Importers. And to make it easy, because I played around to really get a query that this made a difference, I went ahead and based my example on the query from the Microsoft documentation. However, I found that it didn't quite work the way that it was published. I haven't looked at this for several months, so maybe it's changed. But what I had to do was delete some rows from the fact order table that comes into play in this query. So another thing I'm going to do throughout this, you'll see that I'm creating stored procedures. A lot of times I'm going to be showing you differences in the plan, and I want to make sure that things are cached, things that the parameters make a difference, that I don't make a difference in the results because I've accidentally selected an extra space or something like that. So I'm going to be using stored procedures throughout. So this particular stored procedure takes this one argument called quant, and it's used in this query for fact order, inner join, dimension, stock item, and then here we're fact order quantity equals quant. And the fact order table is the column store index. I am also, throughout these demos, going to switch back and forth between the database compatibility levels, and that way I can turn the feature off so that you can see how it looked before, and then turn the feature on to see the new functionality. So in this case, I'm going to set it to 2016 since this is a 2017 feature. Also, occasionally I'm going to be clearing out caches, either the buffer pool or the procedure cache. In this case, the procedure cache, because I want to make sure that we're showing from a very level playing field, starting from scratch here. So I'm going to call this stored procedure twice. I'm going to call it once with this quantity equals 360, and then I'm going to call it again with 78. So when I call it with 360, I get 206 rows, and if I look at the execution plan, I will see that it is using a hash match. For this particular query, that's what makes sense. And I've also got a clustered index scan. For this particular query, this is what makes sense. So when I run it with 78, I only get 5 rows back, but when I look at the execution plan, I'll see that it's identical. I also have the clustered index scan and the hash match. Well, there's only 5 rows coming back, so that might not make sense. It may not make sense for that small amount of data. I'm going to clear the cache again, and run these again, but this time I'm going to do opposite order. So when I run it with 78, and remember that comes back with 5 rows, this time I have a nested loop instead of an index scan, or I'm sorry, instead of a hash match. And my clustered index seek now instead of a scan, because there's just a handful of rows. That's what makes sense. This time we can actually do a seek. Whenever I run this 360, now I also have the same plan. So I really have this parameter sniffing problem going on again. So I get exactly the same plan. So whichever one runs first ends up winning. It ends up getting the plan that's best for that particular query. And of course, a lot of things can go on. Statistics can be updated, maybe index rebuilt, whatever. But for whatever reason, the first one that is saved in the cache, that is the plan that's going to be used. So what I'm going to do here is switch the compatibility level to 2017. I'm going to free the cache again, and I'm going to run these two statements again. So the first one will run with 78, and obviously we're going to get the plan that's good for 78. But it looks a little different. Notice that we have this thing called an adaptive join now. It doesn't say nested loop, which is what I would have expected. And when I scroll down, I see that it's looking at the clustered index twice. Kind of is, and it kind of isn't. So if I look at this one, the clustered index scan, it's there, but it didn't really use that. What it did use was this clustered index seek. And if I mouse over the adaptive join, I'm going to just zoom in here. You can see that the physical operation was an adaptive join, and the actual join type was a nested loop. So that's great. Here's another one, is adaptive true. That's great. We know that that's what's good for this particular argument. So if I change it to 360, I wonder what's going to happen. Is it going to keep that same plan that we saw with 78? So when I take a look at this one, again, I see the adaptive join. If I scroll down, I see something very different down here. I still have two different paths for this data to come through, but in this case, it ignored this index seek, and the data came through with the index scan. And whenever I mouse over, and I'm going to zoom in here, when I mouse over that join, I find out, yes, it's an adaptive join, and this time it used a hash match. And it estimated that it would use a nested loop. But even though it estimated that that's what it was going to do, it was able to switch. So I really, really love this feature. So let's take a look at the next feature in our list. The next one is Interleave Execution. And this one has to do with multi-statement table-valued functions. So these are user-defined functions. In general, user-defined functions have always been a red flag for me when I've been on consulting engagements with query tuning. And one of the things that I've heard people say, and I kind of cringe a little bit, is that sometimes they'll have a scalar function that causes problems, and someone will say, oh, just change that into a table-valued function and everything will be fine. Well, sometimes it will and sometimes it won't, because table-valued functions, by definition, return a table back. However, there are two types. One is called an inline table-valued function, and the other one is called a multi-statement table-valued function. So the inline function, all it is just a query. Okay, it's basically a parameterized view. You can pass in parameters, pass in values, and there's nothing else but that statement. Multi-statement table-valued functions can have lots of things in them. For example, they can have loops. They can create table variables. They can have ifs. They can have all these things, and that doesn't make things better. So by default, the cardinality has always been estimated at 100 for these. So just kind of like what we saw in the last example, 100 might be fine for a nested loop, but under the covers, we really are getting 1,000,000 rows back, or 1,000, even 1,000 rows back. That nested loop not make sense. So one of the caveats with this is that it's got to be static arguments. By static arguments, I mean you could pass in a variable or you could pass in a hard-coded value. But if you're passing in a column, and I'll show you an example of this, this benefit is not going to come into play. So there are no statistics involved, but one of the caveats is that this value that it comes up with is going to go ahead and create the table before it basically optimizes the rest of the query. It's going to save that into the cache, into the plan, and remember that size on subsequent runs. So that is an issue. Again, I'm hoping in the future that there's even better functionality with this. But as of 2017, this is what we have. So let's take a look at how that works. All right, so let me go back up to the top here. In this one, I'm using AdventureWorks, but I'm using a couple of special tables from Adam Mechanic. He's someone who everybody knows, created SP Who Is Active, but he also created this Thinking Big Adventure script that creates a couple of large tables, a product table and a transaction history table. I like to take what he does and then create tables that are different sizes. So in this case, I've created one called Small Transaction History that has around 8 million rows in it. And I've made the Small Transaction History table so it has identical indexes as the original Big Transaction History. So I'm going to turn Statistics IO on, and I'm already at AdventureWorks. So the first thing I'm going to do here is turn on the 2016 compatibility level, and I want to show you how a real inline table valued function works, because I'm going to change it just a little bit in the next query, or in the next little next little example, and you'll be able to see how things can go wrong very easily. So this particular one takes a couple of dates, and it goes out and queries that small transaction history table based on the dates. So I'm going to create that function. So at this point, this is definitely an inline table valued function. It has to just say return tables here, and the only thing that you can have in the body is a query, nothing else. So I'm going to go ahead and run this. I'm querying the big product table, and I am wanting to find out the total number of products sold. And I get back the data, that's fine. When I look at the execution plan, even though SQL Server has just treated this like it's a join, like it's nothing besides a join. So that's an inline. It just is under the covers, it's treated like a join. You can look at the statistics IO and see that we are touching that table. So that's what you get with the inline. So what happens if I change this to a multi-line function? So in this case, all I did was change this return statement to set up the definition and then insert the values into that table. I might think this is an inline function, but it's actually a multi-line function, and I could do a lot more, many more complex things than what I'm showing here. So now I'm going to run the same query, except I'm going to use my new multi-line function, and we'll see what happens. And it still didn't take too long to run. If I look at the messages, now I can no longer see that I was looking at the big transaction history table. From the statistics.io, I don't really see any issues. I don't really see that I'm touching that big table. When I look in the execution plan looks even simpler, which is often a nice thing. However, all I've got, instead of seeing that I'm joining to that table, what I have here is just a table scan of a 100-row table. And if I mouse over, and let's zoom in a bit, my estimated number of rows is 100. And I think even earlier versions of SQL Server, I think if you go back maybe before 2014, it's only 1 row. But it actually returned 25,000 rows. So that's going to make a difference. Probably don't want a nested loop with that many rows. And I really can't see what's going on. This is one of the big frustrations when you're doing query tuning, is that these functions can hide what's going on under the covers. It kind of hides that I'm touching a particular table. So let's take a look at what happens if I don't do anything else except upgrade to 2019. And in this case, I'm just changing the compatibility level. Ooh. Upgrade to 2017, I should say. Okay, I'm going to run that same query with the multi-line. And this time, I still don't see that other table. That's still hidden from me. But the difference is that SQL Server went ahead and created that table to figure out how many rows were going to be in it. So if I mouse over this time, I can see that the estimated number of rows, where is that? Number of rows is 25,000, and the actual rows is 25,000. So now, instead of a nested loop, it realized a hash match would be a better plan. And unfortunately, it's going to remember that size. So if I create another proc, in this case I'm creating a procedure that calls, has a query that calls the function, because I want to make sure that I'm getting cached plan. And I'm going to call this stored procedure with a couple of parameters. And again, inside the stored procedure, I'm calling the function. And when I look at the execution plan, there's my table. And I can see the number of rows is correct. But what if I pull in a smaller date range? In this case, I don't have anything coming back. But when I look at the properties, if I can get it to work, notice that it still expects 25,000 rows. So if your table is going to vary wildly, you need to pay attention to that. The other thing you've got to keep in mind is this is not going to come into play if you are using a value from another table. If we're calling this with cross apply, basically. So let me go ahead and create this. In this case, I am not only filtering on the date, but I'm also filtering on the product ID. And here I'm joining big product to my table valued function using cross apply because I want to send in that product ID, and it's taking forever to run. Oh, it took 4 seconds to run where the other ones were much quicker. That's because it's got to call that function every single row. And if I look at the messages, I don't really see what's going on. If I look at the execution plan, that looks like it might make sense, but if I mouse over, I can see that it's still expecting 100 rows to come back. So if it's a cross apply where we're pulling in a column from the outer query, we don't have that inlining yet. So let's take a look at the next example. Memory grant feedback. So sometimes you have a query, and maybe because the statistics are out of date, might be a reason, could be some other reasons, that the memory grant that's assigned is not correct. If it's too small, then the memory might spill to disk, spill to tempdb. If it's too large, it's possible that that query is taking resources that could be better used by other queries. So this one's kind of interesting. It does update the cached plan, but it will adjust. If things change quite a bit, it might adjust again, but if it changes too often, it's just going to give up. It's just going to say there's too much variability here. We're not going to use this feature. This was introduced in 2017 for batch mode. Again, that means a column store index. And in 2019, the functionality was added to row mode. So it does work best when there is a consistent number of rows coming through. And it is Enterprise Edition only at this time. So let's take a look at how this one works. And that is number 3. And this one, I'm using an example from Greg Larson's article out on Simple Talk. And in fact, Greg wrote several articles on these features. So I would say just go out and maybe to Simple Talk and just search for his name. You want to find all the articles. And they're really helpful to me to learn about these features. In this one, I'm using Wide World Importers. And I'm going to set the compatibility level to 2016. And the first thing I'm going to do is just run this simple query to get a list of the sales orders. And when I look at the execution plan, I see that there is a warning. Let's zoom in on that. There is a little warning triangle on the select. So why is that? If I mouse over, I can see that this particular query asked for too much memory. Okay, it could be the other way. It could be too little memory. Either way is a bad problem. So what I'm going to do here is switch to 2019 compatibility and run the query again. And I'm going to run it, let me run it once. And we will see, if I go to the execution plan, I'm going to click and go to the properties over here, and there's this new memory grant info section. So the real important thing to look at here is memory grant feedback, and I could probably feedback adjusted. Okay, so that's what that says. Is memory grant feedback adjusted? No, because that was the first execution. So it's got to run first and see that there's a problem. So on the next execution, We can go back and take a look again. It still looks like it's got an issue. Let me run it one more time. And now that warning is gone. So if I take a look at the properties, let's click and click. Now we see that yes, we are taking advantage of this, and we have adjusted the memory to match the amount really needed. So one thing to keep in mind is that if it adjusts wildly, SQL Server will not try to keep adjusting. So here I've got a stored procedure, and I'm going to run it in a loop 35 times, or maybe it looks like 34 times, but I'm going to go back and forth between two different values. And let's wait a few seconds for that. And what I'll do is kind of scroll down to the very bottom one once it's done and show you, there we go, and show you what to look for there. So here I don't really have the problem. It says I don't have the problem, but if I look at the properties, it says, no, we're not using this feature. The feedback has been disabled. And the reason it's been disabled is because there's too much fluctuation. So this, again, sounds like a really cool feature, and if there's not a wild swings in the amount of data based on the parameter, it will help you with memory. Let's take a look at the next one. Now that's the end of the 2017 features. Now let's talk about 2019. Table variable deferred compilation. Oh wow, so I remember when SQL Server 2005 came out, there was this really big myth about table variables, that table variables were always better to use than temp tables because theoretically they were only lived in memory and never touched tempdb, which is really not true. And there's some other issues with table variables. For example, the cardinality estimation is just 1. And you know, if you just have something coming back as 1, it's always going to choose a nested loop, even though a hash match might be better. So what this particular functionality does is deferred compilation until we find out how many rows are in that table variable, and then come up with the rest of the plan. So the plan can adjust based on the actual row count, and that row count is now stored in the cached plan. So let's take a look at how that looks. And that's number 4. I'm going to use AdventureWorks in this one. And here I have a stored procedure that takes a couple of dates and declares a table variable. Then it inserts data into the table variable based on the dates, and then uses a table variable in a query that's returned. So let's execute that. I think I did it. Okay. And I'm going to start out with the compatibility level in 2017, and then I'm going to run the stored procedure with a couple of dates. And my window is way down here. So when I look at the execution plans, I see I have 2 plans here. One of them is for populating the the table variable, I should say, table variable, and the other one is the query that's returned. So let's see if I can pull this bottom part up so we can see it better. Maybe, maybe not. Let's do that. Okay, so you can see we've got some problems in this execution plan. We've got spilling to tempdb in the sort. We've got a nested loop, even though we've got 121,000 rows. And if I look at the properties here, I'll see that the estimated number of rows is just 1, when in actuality, it's over 121,000 rows. So that 1 affected that plan. That is not what we would expect with this large amount of data to come back. So if I switch to 2019 compatibility level and execute exactly the same statement, and scroll down so I can see this bottom one, notice that the plan changed quite a bit. I got rid of that sort that spilt to tempdb, and now I'm using a hash match, which makes a lot more sense for that large number of rows. So that matches now. However, in this case, I'm using a smaller number of rows. Here it was like 4 years worth, it looks like, and here it's just 1 year's worth. And now, when I look at the execution plan, I still have that same plan, which still is probably fine. I would expect that this would still be the plan, even if I had run this first. However, notice that I have cached that original number. However, in this case, I really think that the plan would still be correct. That would still be what we would want to see. Oh, I'm not looking at the right thing. Oh yeah, I am. I just scrolled up. So again, this is what it's expecting, and 5,000 rows is still a lot. So if you still had that table variable in the thousands of rows, I think you'd still have the same plan. So even though it's remembering that value, I think it's okay. I think it's really helping out quite a bit. Much, much better than that estimate of 1 row. So let's take a look at what's next. Batch mode on Rowstore. This is my favorite feature in the 2019 group. So what this one does is add some functionality that was previously only available in column store index queries to straight Rowstore queries. So if you have a query that returns a large number of rows, and it's going to be, I played around 123,000 or greater before this kicks in, and it has to have some aggregates in it. So what SQL Server will do is kind of break down that. It's not parallelism, but it's kind of a similar idea where we break something down, do the calculations, and then bring it back together. This will definitely decrease CPU requirements when it's in use. And my favorite thing about this is that it will improve window aggregate function performance. So window aggregates are part of the group of window functions, which chances are you've heard me talk about in the past because I've probably presented on it 75 times. But a couple of the functions, the window aggregate in particular, and some of the statistical functions don't scale really well. So this particular feature actually helps them scale, and it makes them perform really, really well. This does require Enterprise Edition. So let's take a look at how this works. So on this one, I'm using AdventureWorks 2019. I'll switch to 2017 compat, and I'm going to drop the clean buffers just because I want to kind of look at how long it takes. So what I'm going to do is get a count of that big transaction history table. And I've got some times of different times that I've run this. This time it only took about a second. If I look at the messages, I can see it took about a second and a half to run. That's really not too bad. But what I'm going to do here, and this one definitely meets those requirements. We've got 31 million rows, and there is an aggregate. So it really does meet those requirements. I'm going to run this one to set the compatibility level to 2019. And I'm going to go ahead and drop the clean buffers again just to make sure that running it the previous time doesn't affect this time. And I'm going to run the same query again. And you can tell that by previous trials of this, it would run in less than a second. So, and this time, again, about a half a second. So that's pretty good. I have decreased CPU time. This one looks kind of odd. It looked like more CPU time. But in general, it's going to be less time to run. And that can make a difference when you have large, for example, data warehouse reports where there are lots and lots of calculations involved. So let me go ahead and show you this one. I mentioned windowing functions. Most of the windowing functions perform great. My favorite functions, lag and lead, they are amazing. They perform wonderfully. They scale really, really well. But there is a situation with for example, the window aggregates. So it's just a regular aggregate with the over clause, where they don't really scale that well. And that's because a work table is created in TempDB. So let me go ahead and set the compatibility level back to 2017, and I'm going to run this query. Again, it's on the big transaction history table, and it's going to take a bit of time to run. It took 5 seconds to run, and if I look at the statistics I/O, you can see that there was a work table that took almost 400,000 reads. So that's where this bottleneck is. If I look at the execution plan, I'm going to see these table spool operators. When I see those are bad news. That means a work table created in TempDB. So let's take a look at what happens to this query when I change it to 2019 compatibility. The same exact query. And it took 3 seconds instead of 5 seconds. And I have done timings that I show in my, I'm not doing it at this past summit, but my window function performance, where I have done timings to find out, really do some great comparisons. And this definitely makes a difference. So if I look at the messages and scroll down, you'll see I still have to query that big transaction history table. I can't get out of that. But my work table is now 0 logical reads. That means that this table is created in memory. And if I look at the execution plan, I'll see something very different. There's a new operator called a window aggregate operator. And when I see this, instead of that table spool, I know that is really good news. So I'm pretty excited about this feature. Now let's take a look at what's next. Scalar UDF Inlining. I've talked a little bit about the multi-statement table valued functions. These are the scalar functions, the ones that you might put inside a select list or in a where clause. Oh, I hate to think of that. And these return one value. That's why they are scalar. Okay. Unfortunately, the query itself has got to call that function for every row in the results. And it also keeps the query from going parallel when it should be. So what Microsoft has done in certain situations is allow that code in the UDF to be refactored right into the query, just as if you had put the formula or whatever it is right into the select list. There are many, many, many limitations where this will not work. But when it does work, it's like magic. and it can also turn the plan into a parallel plan when needed. So let's take a look at how this works. So this is Demo 6. I'm going to turn Statistics IO on. And one of the things about UDFs is that the Scalar UDFs are really a black box to that execution plan. It can't really see. And you can have a lot of things in there. You could have loops, you could have ifs, you could have other queries, you could have table variables, and a mixture of all those things. So, and it could call other functions as well. So let's start out with changing to SQL Server 2017 Compat. And in this particular one, I'm going to throw the results away because it would take a long time to populate the grid. So I'm going to throw them into a temp table. Just pretend, for example, that you work for AdventureWorks and you have this nice little formula to determine markup. And we're going to join big product to the small transaction history table and just perform this calculation. Unfortunately, you use this formula in many, many queries, and you've been told that you shouldn't be using that exact formula in the query, that we should use some kind of a function to improve reuse. So let's make it a function. Why not? So we've got a little function that just runs that formula. So if down the road, if that formula changes, we can just change it in one place and it'll affect all our queries, and our query will actually look prettier. So imagine that this was a more complex formula. It's really not that much difference. So let's go ahead and try it out. I have the same query that I had before, except that in this case, instead of having that formula explicitly spelled out, I'm calling my UDF. So we run the query, and I've had this, I may end up killing it. Let's see, I didn't grab everything I need. I may end up killing the query if it takes too long to run, because it has taken anywhere from 30 seconds to a minute and 10 seconds to run when I was experimenting with the query. And already it's up to 10 or 11 seconds. I don't remember exactly how long it took when I just ran it with the formula, but I believe it was like 3 or 4 seconds. I'm just going to kill it because this is just taking too long. Well, I'm not going to look at the execution plan because it's really, this will just show up as a calculation or a. So what happens if we upgrade to SQL Server 2019, which I'm simulating by setting the compatibility level to 150. And we're going to continue to use that function, but in this case, the query ran in 1 second. Ran really, really quick. So you can also add other things. For example, this particular function has an if statement and it also has another query. So even though it's got those two things in it, this particular one is still inlineable. And if I run this query that calls this new function that I just created, the really cool thing is that in the messages, I will see the, so in this case, I'm only calling product in the outer query, but this one will actually let us see the other tables that it's calling. And if I look at the execution plan, it just looks like a join to those. If I can, it just looks like a join on those tables. However, there are many, many issues, many limitations, I should say. And check the documentation to see that list. It's pretty long. I'm going to create this one that is just like the previous one, except that I have a get date. And this is one of the limitations. Yeah, I'm just going to create it. And I have this little query here, this is a very, very nice little feature. You can run this query, filter it, for your own functions to see which ones are inlineable. And I think I have that date function twice because I've played around with another version of it. So if it order quantity for year, that's where I was just passing in the year, is inlineable. If I add a get date, it's no longer inlineable. The one where I've have an if statement, it is, and the one where this is just another example of the same one. I just didn't clean up. So it is a really great thing. I'm very, very excited about it. However, you have to pay attention to the list of limitations and just keep that in mind. So let's take a look at the next one, Approximate Count Distinct. So this one's a little different because it's a brand new function. It's not a feature or functionality. And this one will run just by using it. This is the only one where you've got to change some code. So imagine that you have data flying into a table very, very fast. Maybe it's a log file. And you need to get a distinct count of that. And you need to do that pretty often. And if you don't really care how accurate it is, maybe somewhat accurate, you want it to be ballpark, but it doesn't have to be exact. You could do a count distinct on that column, but in this case, we're going to use this brand new function called Approximate Count Distinct. It is not going to be exact. It is going to be kind of like an estimate. What I found is that it really makes a difference if it's an unindexed column. It doesn't matter if it's a regular indexed column. If it's an indexed column like on a primary key, you're really not going to see the benefit. And what this does is it does save memory, and you're less likely to have spills to disk. So let's take a look at that. Okay, I'm using AdventureWorks again, and this time I'm going to use a heap that is a copy of the big transaction history table. So it's a 31 million row table, and I'm leaving off the indexes and keys. So I'm going to drop the clean buffers again, and this is the old way to do it. And I don't really have to switch the compatibility mode with this one since it's a new function. It could be I'm not sure how far it can go back, but let's say if it's in 2017, it doesn't matter. So if we execute that and wait, it took 2 seconds, and you can see that I got back this actual count. But again, I'm going to drop the clean buffers and run this one with this new function. And it came back in 1 second. So again, the number that came back is not exact, but it is close. So I have one more thing to talk about, and that's how to control these IQP features. You've seen me, except for the very last demo I did, turn the features on and off by changing the compatibility level. So what you can do is turn all of them off just by going to a lower compat level. Most places won't want to do that. So if you decide that there are some features you don't want to take advantage of, you can change a database property. However, I think you're more likely to find that there's an individual query or a couple of queries here and there that don't perform the way you want, and you want to disable it for them. So I have in the slides, I'm not going to go through these except to tell you that in the 2017 features, by changing the property, they changed the name of it. And also, I've got the query hint. So I know that this is small font, but to keep it from wrapping, I did that. And there's the 2019 features. So just go ahead and download the slides, and then you'll have all of these. So let's take a look at one example. And I love this example because this is something that could come up. So one thing I might do is say, okay, I want to make sure that I'm turning this on across the board for all the features. And then I'm going to create this function called missing table. So this function, this is going to be that for the UDF inlining. What this function does is check to see if missing table exists. If it does, let's get a count. If it doesn't, let's get a count from production product. So, kind of a silly example, but there could be something like this in the real world. So if I just run this now in 2019 compat mode, I did get an answer back, but I also got an error. Because it's inline, it's expecting to see that missing table. Because remember, if there is this thing called deferred compile, I was able to create that function even though missing table isn't there. And then whenever I try to run it, that's when the problems come up. Okay, so in this case, if missing table existed, it would have been fine, but since this is inlined, kind of hard to wrap my head around, but because it's inline, it expects that missing table to be there. It's not treating it like a function per se, it's treating it like that code was in the query itself. So let's say I decide to turn off that UDF inlining. Now, when I run the query, it just runs or run the function. It runs as expected. I get that answer back. It treats it like it would a regular function. As long as my code doesn't hit missing table, it's going to be fine. But you know what? There are a lot of other situations where this functionality would be really great. So I want to turn it back on. And again, of course, I get this problem back, but what I can do is use this query hint to disable it just for this query. So run it, and there we go, no error. And this functionality of turning it off and on, this granular control that you have, is really, really great. I don't think that you really will need it that often because for the most part, these features really do improve performance. But just in case you need it, it's there. So let's go back to the slides. And I want to remind you again to submit your session evaluation. As it says, your feedback is important to us, and you might win some prizes. And I thank you so much for watching this session today. You can find me on Twitter at Kathi, and my email at redgate is kathy.kellenberger@red-gate.com. And well, I will stick around for a few minutes to see if you have any questions. Thanks so much.